Summation, or sigma notation, is a shorthand notation used to express the sum of a series. So the letter sigma is a Greek symbol, and it's the uppercase letter sigma, and it just means summation. And you'll see this symbol a lot in science classes, math classes, definitely in statistics. We use this a lot, and it just means to sum. All right, so let me explain the notation a little bit. What you're going to see at the bottom, that is where you start. So like, for example, if this is j equals 1, what I would do to get my terms is I would start by substituting in 1. And then whatever's at the top of the sigma right here, that is where it ends. This is the end number. So whatever that is, that's where you'll end. So like if the bottom is 1 and this number was 5, you would sum from the first term to the fifth term. And then whatever's on the inside right here, this is just your general formula. So I've got it called a sub j, but I mean it's whatever the formula is, and you just, the letters will match up and you'll see how that works. So looking down right here, I kind of just abbreviate this for you. This is where we start, this is where we end, here's our formula. So let's look at an example. Let's say you have the summation from 1 to 4 of 2n plus 5. So here's what you do. You'd start by substituting in 1. And then you count up using consecutive integers, and you would end with substituting in 4. So you can see how that works. 2 times 1 plus 5, 2 times 2 plus 5, 2 times 3 plus 5, 2 times 4 plus 5. And then we would calculate what each of those terms are. 7 plus 9 plus 11 plus 13, add them up, and we get that our answer would be 40. A lot of times, if it's a simple little formula, once you get the pattern going, you don't really have to continue to substitute in, because we can see this is a linear expression and the slope would be 2. So once you get that first term, really you just know that you just keep adding 2 to get the next terms until you get to that fourth term. Okay, so let's do an example together. Write the first 4 terms and the last term in the series. And this one is from 1 to 100 of 2n minus 3. Then find the indicated sum. So since we're going to find the first 4 terms, pretty much we're just using that formula, 2n minus 3. And we're starting, we substitute in 1. We substitute in 2. We substitute in 3. You kind of get the idea. And then, since it says to end at 100 right here, to get the very last term, we're going to substitute 100. So I've just got these little ellipses here, and I went over to the 100th term. So this is what this would look like when we write it out. It would, the first term was -1. And then the second term was 1. The third term was 3. The fourth term would be 5, because we know that it's just increasing by 2 each time once we get that pattern. And then we'd put plus, dot, 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 plus, and then we'd have 197 as that 10th term. And this is just showing work so that you can show, okay, here's the first few terms, there's the last term. All right, but then we want to actually find the sum of all these terms. Well, guys, I do not want to find all 100 terms and then add them up. So what we're going to do is use our summation formula. Because this is an arithmetic series, it has a common difference. We can just use our formula that we learned in the previous lesson. S sub n is equal to n divided by 2 times a sub 1 plus a sub n. So in this case, we would have S sub n, or S sub 100, because we were adding the first 100 terms, is equal to 100 divided by 2 times -1 plus that very last term of 197. And so we clean that up, that's 50 times 196, and when we calculate that, we get the sum is 9,800. And so we would just come over here, and we would write that, 9,800. So a lot of times with these problems, you'll see it, it'll actually, so they can see that you understand the process, it'll ask you to calculate the first couple of terms and the last term, and then actually find the sum. This part is going to be backwards. It says, write the sum of the first 10 terms of 80 plus 75 plus 70 plus 65 using sigma notation. The first thing we have to do, folks, is come up with the formula, just like we did in the previous lesson. So let's look at what we have here. We know that our first term is 80. We know that we want to find the sum of the first 10 terms, and we can clearly see that we're subtracting 5 each time, so our common difference is -5. So coming up with this formula, we would say a sub n is equal to 80 plus n minus 1 times -5. Now, again, from our previous lesson, you may want to rearrange that. It might make it easier to distribute. So that's really saying 80 minus 5 times n minus 1. So that we then distribute the negative 5 to n and the negative 5 to negative 1. So we have a sub n is equal to 80 minus 5n plus 5. And we come up with the formula a sub n is equal to 85 minus 5n. You can always check your formula. You can use your calculator, put it into y equals, check the table, and make sure it's producing those terms. So then we're going to put this together. So we're going to draw our sigma. At the bottom, we're going to start with the first term. And then because we want to find the sum of the first 10 terms, we'll stop with the 10th term. So the bottom is always where we start. The top is our upper limit where we end. And then you put the formula for finding each term. So then we just pop the formula for finding each term in right here. Sometimes students get confused and they think that you use the summation formula here. That is not the case. You would use the summation formula to actually find the sum, but the sigma notation is represented by the formula for finding each term of the series. And then this would be our final answer. Something I want to make sure I point out, the bottom doesn't always have to start at 1. It can start at any number. It can start at the 5th term, and then you could add to the 10th term. So if you ever want to check and make sure you're adding the right number of terms, it's always the difference between the top and the bottom, and then you add 1 to it. So for example, 10 minus 1 is 9, but then when I add 1 to it, there's actually 10 terms I should be summing. Okay. Pause the video, do the try these A. When you are finished trying them, start the video back and let's see how you did. So for the first one, it has us summing from the first term to the 4th term. So all we're doing is just substituting in 1, substituting in 2, substituting 3, substituting 4. And a lot of us can just do this in our head. 5 times 1 minus 1 is 4. 5 times 2 minus 1 is 9. 5 times 3 minus 1 is 14, and so on. And then we just add those terms up. The second one, same thing. We're adding from the first term to the 5th term. I feel like when you're not adding that many terms, it's just easier just to write out the terms and add them up. However, had this said to add from like the first term to the 20th term, I would have probably figured out what's my first term, what's my 20th term, and then used the formula like we did in the first example above. All right, this part C. This one is one that kind of confuses people because it doesn't start at the first term. And I know that's weird because you're probably like, what? There's not a 0 term. You just have to go with it. So we substitute 0, and then you always count up with consecutive integers. And then we would substitute 1, and then 2, and then 3. And this is not arithmetic. The first two are arithmetic. They make that linear pattern where they're adding or subtracting the same number. This one's a quadratic pattern, so it doesn't have to be an arithmetic series. It can be any type of series. You just have to use the formula and go with it. And we get that the answer is 14. Let's check out this last one here. So I can see that the first term is 1. I can see the common difference is 4. And then I can see that there are, when I count them up, 7 terms. So I'm going to make this easy on myself. I'm going to put n equals 1 at the bottom. I'm going to put 7 at the top. And then that way I can just use our formula for an arithmetic sequence because this is arithmetic. And so I just pop into our formula. I get the formula 4n minus 3, pop it right there, and we have our sigma notation. Okay, flip over to the next side and do the try these B. When you're finished, pause the video and start back. Now, when you get to the last part where it says rewrite each series using a sigma notation, they may not be arithmetic. You're just going to have to use that good smart brain of yours, that mathematical brain, and try to figure out what would the formula be. Okay, so let's look at the first 3. So again, these don't necessarily start at 1 at the bottom. So you just have to go through it. 0, 1, 2, 3. This one is pretty simple because it's just the straight up those numbers. And then we add them together to get that sum. The next one, it starts at 2, ends at 4. So what I mean by that difference, if I say 4 minus 2, that is 2. There's actually 3 terms. It's always one more term than the difference because it includes the second term and the 4th term. And then you just use your formula. And you substitute it in. You can see those 3 terms and clean it up, and we get that the sum is 20. The next one, the formula, it's got a couple of pieces to it. So I just wrote out each part, and now all we're doing is substituting the 2 in, and 3, and then 4, and then 5, and then 6, and then I figured out what each of those terms are and add them up. Make sure when you're doing this, you're not separating your terms with commas and that you're using pluses, because sigma means to sum. It doesn't mean what is the sequence. It means what is the series. And that's a big thing between sequence and series. Sequence is separated by commas. A series is separated by plus signs. All right, then this next one. So these got a little funny because you had to figure out the pattern. They were not arithmetic. And it just kind of pushes your brain again a little bit. So what I noticed about number 4 is that it multiplies over and over by 3. Well, anything that is multiplicative is where we're using powers. So if you rewrite it using those powers, the first one is 3 to the first, then 3 squared, 3 cubed, 3 to the fourth, 3 to the fifth. If you can rewrite it like that, you can see the pattern where there's then 5 terms, start at 1, end at 5, and then the formula would be 3 to the nth power. The next one, I could see that that was a list of our perfect squares. And guys, these are the types of things as an honors pre-calculus student, we've got to be able to recognize these patterns. Not everything's going to be just adding and subtracting or multiplicative. There's all kinds of patterns out there. So when I rewrite them as our perfect squares, I can see that this starts at 1, ends at the 5th term, and our formula would be n squared. Where the last one, if you kind of can rewrite that first part as 1 over 1, and then look, that would be 1 over 2, 1 over 3, 1 over 4, 1 over 5. We can see that formula is 1 over n, where n equals 1, and then it goes to 5. All right, so we will work on the practice when we get together in class. For those of you who are virtual, you will need to be doing it virtually.